So here in this problem, u is given as x raised to n f of y upon x plus y raised to n g of x upon y, and we have to prove that x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square is equal to n into n minus 1 into u. Now to prove this result, there are two methods. Now the one which is lengthy, or which I'll say that which is a lengthy method, is by differentiating this u with respect to x twice to get dou square u by dou x square, then substitute that value over here, then again differentiate u twice with respect to y to get dou square u by dou y square and substitute that value over here, then differentiate that dou u by dou y with partially with respect to x to get dou square u by dou x dou y and substitute that value over here, then solve and get the value as n into n minus 1 into u. So definitely it is a lengthy method, and to get the value of this function will become a tedious solution. So for that, what we'll do is we will use the Euler's theorem over here, or I'll say we'll use the corollary of Euler's theorem over here, because if you'll observe the left hand side, then it exactly matches with the statement of corollary of Euler's theorem. So that statement is like this, that x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square is equal to, the formula is n into n minus 1 into u only. So to use that corollary, we have to prove that given function u is homogeneous function, and then only we can apply the corollary of Euler's theorem. So first of all, we'll prove that the u or the function u is homogeneous function, and for that we will put x equal to xt and y equal to yt in function u. So here I'll say putting x equal to xt, y equal to yt in u, we get u of x comma y equal to, this will become x raised to n t raised to n f of yt upon xt plus y raised to n t raised to n g of xt upon yt. Next, this t will be cancelled. We can take t raised to n common, and in the bracket we will get from here x raised to n f of y by x plus y raised to n g of x upon y. So we are getting this original function back. So we are getting u of x comma y. So therefore the value of u of x comma y is equal to t raised to n u of x comma y, and therefore here u of x comma y is homogeneous function of degree n. So here I'll say therefore u is homogeneous function of degree n in x and y, and therefore we can apply the corollary of Euler's theorem over here. So therefore here I'll say by corollary of Euler's theorem, we can say that for function x, x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square is equal to n into n minus 1 into u, because here the degree is n and the function is u, and by using the corollary we got the required result. Thank you.